All right, here we are, quarter 3, week 7, day 3. We're going to solve a multiplication problem and a division problem, both with decimals. Okay, and we do it very differently from one to the next. So let's just go ahead and write out the multiplication problem here. We have 72.32, and that's times 0.04. We did line up the decimals. We don't have to when we're multiplying. All right, let's go ahead and do this. 4 times 2 is 8. 4 times 3 is 12. 4 times 2 is 8 plus 1 more is 9. And 7 times 4 is 28. Okay, then we could do the 0, put a little x here and say, well, 0 times 2 is 0. 0 times 3. Okay, and we could do that again for the next one, but that's completely unnecessary. Okay, at this point, all it matters is that we have the 2, 8, 9, 2, 8. And then at this point, we can just take the number of digits behind the decimal, which is 1, 2, 3, 4 digits. Move the decimal 1, 2, 3, 4 places. And then the answer is 2.8928. All right, so there's our answer for the multiplication problem, 2.8928. Now let's just do the division problem. But we do have a situation here where the number that we're dividing into the other number, okay, because it's this number divided by this number, we have to have the divisor not be a decimal. So we're going to have to move it over 2 places, rewrite it, and solve from there. All right, so I rewrote it without the decimal in the divisor. Okay, so does 8 go into 5? Nope. Does 8 go into 52? Yeah, we can go into it 6 times. 6 times 8 is 48. Subtract that. Okay, so we have 52 minus 48. And that would give us 4. Okay, so we have 4 here. We're going to bring down the 1, 41. How many times does 8 go into 41? Well, it goes into it 5 times, because 8 times 5 is 40. 1 minus 0 is 1. Bring down the 6. Does 8 go into 16? Yep, 8 goes into 16 twice. 8 times 2 is 16, which means our remainder is 0. So we just bring the decimal up. The answer to this one is 6.52. Kristen bought a pack of 12 pencils for $1.25. How much was each pencil? Okay, so 12 pencils is $1.25. To find out how much it is for one pencil, you have to divide by 12, right? 12 divided by 12 gets you 1. So you're going to have to do the same thing with this one. So if you take $1.25 or 1.25 divided by 12, that's going to give you 0.104, or basically right around 0.10, which would be 10 cents. So each pencil is basically 10 cents. Very slightly over 10 cents, but in this situation, we're just going to say each pencil is 10 cents. Write an expression that represents the sum, okay, here's our key word, sum of R and 7. Sum means we're doing what math? Yes, addition. So representing the sum of R and 7, all you have to do is R plus 7. There it is. That is an expression that represents the sum of R and 7. All right, let's do the next one. All right, a typical human stomach can hold up to 4 cups of food. Write an inequality that represents how many cups of food a stomach can hold. Okay, so, well, we're going to do an inequality, which means we know we're going to have a variable on one side. And since we're talking about 4 cups of food, I'm going to put that there. Now we just have to decide what goes between it. All right, so a typical human can hold up to 4 cups of food. Looks like it could actually hold exactly 4 cups of food. So I'm going to put the little line for the equal sign. And then it says it can hold up to 4 cups of food, not typically more than that. So x is going to be a number less than 4. So x is less than or equal to 4. All right, there's our inequality. So that represents the fact that a human stomach can hold up to 4 cups of food. All right, that's all you have for that. Find the rule, solve for n. Once again, you put a 10 and you do something to the 10 and it comes out, or it ends up being a 14. Okay, so you have the 10, something happens to the 10, now it's 14. You have a 13, something happens to the 13, now it's a 7. You have an 18, something happens to the 18, and now it's a 22. So what is happening with the 10, the 13, and the 18? I think I have it figured out. I think you're adding 4. 10 plus 4 is 14. 13 plus 4 still works, is 17. 18 plus 4, once again, it's working, so that is our rule, which means our rule is y is going to be whatever x is plus 4. All right, and then we have to solve for n, so what number plus 4 will give you 19? Yep, n equals 15. 15 plus 4 is 19, so n equals 15. All right, we have an ice cube tray, is what that's supposed to say, tray. An ice cube tray holds 12 ice cubes. Each ice cube is 5 centimeters on each side. What is the volume of all 12? Okay, so let's find the volume of one of them. So here's a little cube, and each side is 5. To find the volume, it's length times width times height. So it's going to be 5 times 5 times 5. So if you do 5 times 5, that's 25. 25 times 5 is 125. Okay, so one of the ice cubes is 125 centimeters cubed. So at this point, we have to take that and multiply it by however many cubes there are total. So if you take 125 times 12 times 12, that's going to end up being 1,500. So the volume of all 12 cubes combined is 1,500 centimeters cubed. All right, there's your answer for that one. Jonathan's math scores were 87, 93, 85, 62, and 95. What is his mean? All right, so do you guys remember what is mean? All right, and once again, mean is the average. You add up all the numbers and divide by the number in the data set. Remember, the median is the number in the middle. The mode is the number that happens most often in a data set, and the range is the difference between the highest number and the lowest numbers. So we're going to find the mean for these numbers in this problem. All right, so we're going to add up the numbers, and we did that. We did 5 plus 5 plus 3 plus 7 plus 5 plus 2. That's 22. We carried the 2. And then we added all of this up together and came up with 42. So the total is 422. And then there are how many numbers in the data set? There are 5 numbers in the data set. So we're going to take 422 and we're going to divide 5 into that. Okay, so if we take 422 divided by 5, that equals 84.4. All right, so the mean, okay, what is the mean score of this one? It is 84.4 is the mean of this data set right here. Okay, let's move on to the next one. All right, now we need to find the median and the mean of this data set. So do we notice that in this data set, do we have them lined up from least to greatest, or do we have to rewrite it? Yeah, we're definitely going to have to rewrite it because we always like to do that when we're working with data. So let's go ahead and do that real quick. But real quick, let's remember the mean is the average, which means we add them all up and divide by the number in the data set. Median is the number in the middle. And just for good measure, mode is the one that happens most often, and the range is the difference between the highest and lowest. But these are the two we're going to be doing right now, the mean or the average, and the median. All right, so first we're going to look for the median, which is the number in the middle. Okay, so let's start kind of just canceling out on each side until we get to the middle. Once again, let's see if we have just one number in the middle or if there's two numbers in the middle. Well, there's our number, 32. So our median is 32. All right, that was pretty easy to find. Now we need to find the mean, which means we have to add all of these up and then divide by, how many is in the data set? 1, 2, 3, 4, 5, 6, 7. So we're going to have to add them all up and then divide by 7. So if you take 159 plus 65 plus 33 plus 32 plus 28 plus 22 plus 20, it is going to equal 359. All right, so that's our total. So what do we do to find the actual mean? We have to divide that by, yes, 7, because there's 7 numbers in the data set. So we have 359 divided by 7, and that's going to equal 51.28, something like that. So we're going to say 51 point, it's actually 2857, so we'll just say 28 and then round the 5 up to a 6 since the next number is 7. All right, and so that is the mean. All right, so the last thing that they want us to look at is which reflects the best measure of center. So if you look at these numbers, 51 would kind of be located in this area here, and 32 is located right there in the middle. So between the two, which one seems to reflect a better measure of center? Well, it's going to be the median. Okay, and this is a good point to bring up, because the reason why is because we have this number right here. All the rest of these numbers kind of go together, but then all of a sudden we jump all the way up to 159. Okay, that number is called an outlier. And that's going to be important to know. Okay, so anytime you have a number that's an outlier, it's going to skew the mean. Okay, so that's all the rest of them don't really get affected, but the mean does, because it's going to add in this extra number. It would be like trying to find the average age of a student in 6th grade and then having a 90-year-old come into the classroom and finish their 6th grade material just because they never did it before. So the average age in that class would go way up, right? So you would have to add in everybody's age plus someone who's 90 years old. Okay, so if that's the case, then it's going to look like everyone's like, 16, 17 years old in that particular classroom. Is that accurate? Nope. Everyone's pretty much right around the same age, maybe 11-ish, 12-ish, I guess. And you have one outlier that's completely messing it up. So in that situation, the mean would be a bad idea, but you can use the median and probably the mode in those situations. All right, so there we go. So there's the outlier, 159. So that's going to make the mean not a good measure of center. If this was closer to these numbers, then probably the mean would have been the best measure of center. All right, that's very important, so I took a little time to explain that, and I think that's it for the day. See you next time.